This is Engage New York, Module 1, Lesson 3. This is concept development. So we are starting here with the idea and looking at how your numbers change. And we're looking at the powers of 10. So we're going to be looking and understanding what the word exponent means. Now, based on what I just showed you before, the exponent does have, it's shortening things. So 10 to the first is equal to 10, right? Now, 10 to the first also has an exponent attached to it. How many zeros are in 10? Yes. So the exponent attached to it is 10 to the first because there is 1 0 with it. Now, what's 10 times 10? Could it be 100? Very good. And so its exponent would be 10 to the second. Then, 10 times 10 times 10. What could that number be? So 10 times 10 times 10 is 1,000, which is 10 to the third. 10 times 10 times 10 times 10 is 10,000, which would be 10 to the, show me with your fingers. Nice, 4. And then there's 10 times 10 times 10 times 10 times 10, which would be 100,000, which is equal to 10 to the, what? Show me with your fingers. Yes, 10 to the fifth. Then 10 times 10 times 10 times 10 times 10 times 10 would be 1 million. And that would equal 10 to the, show me with your fingers. Yes, 10 to the sixth. Okay, let's write down right here where it says exponent. So we can use an exponent to represent how many times we use 10 as a factor. So up here, we used it 6 times. We used 10 5 times. We used 10 4 times. We used 10 3 times. We used 10 2 times, and we used 10 1 time. Yes, 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 yes? All right, so we have 10 to the 6th, 10 to the 5th, 10 to the 4th, 10 to the 3rd, 10 to the 2nd, 10 to the 1st, right? So the number of zeros up here matches how many, this is the exponent. The exponent represents how many times we have multiplied by 10 as a factor, and that's how many zeros you're going to find in that number. What I'm asking you to do right here is I want you to write 10 to the 5th power as a product of tens. And what I mean by that is I'm going to say 10. How many times am I going to multiply by 10? Show me with your fingers. Yes. Times 10, times 10, times 10, times 10. 1, 2, 3, 4, 5. Was that really hard? Did you want to cry? No? Okay, good. I'm glad you didn't want to cry because that would make me sad. So how many, where would this be? Here's 1, 2, 3, 4, 5. So this is this number, correct? 10 to the 5th would be right here. Now, 100 times 10. Oh my gravy. Problem 3, we're just comparing the expressions to the ones we've already talked about. These have factors other than 10, so we could, I wonder how we could write that to make that kind of like this up above. How could I write that, do you think? Okay, so we could write this as, this is 110, this is 210. So this is 10 to the second, and we're multiplying by another 10. So this could be 10 times 10 times 10, or also 10 to the third, and 10 to the third is equal to 1,000. Now, problem 4. Problem 4. Here we go. Problem 4. 3 times 10 to the second. So if we go 3 times 10 times 10, what does that equal? Remember, our number gets bigger, so our number is going in this direction on the place value chart, and our decimal is going to move in the opposite direction. So if I'm just looking at 3.4 times 10 to the third, how many times, show me with your finger, how many times you're going to move your decimal in this number? Emmanuel, are you listening? Yes, you guys are absolutely correct. So we're going to multiply by 10 to the third, which is really going, it's getting bigger. 1, 2, 3. So our number is going to be there is our new number. Okay, let's do a couple more. Now, problem 5. 700. Oh gosh, now we're dividing by 10 to the second. So now, our cheat sheet, when you divide a number by 10, 100, or 1,000, your number gets smaller. Your numbers go in this direction, smaller on the place value chart, and your decimals is going to move in the opposite direction. All right, so now we have 700. And remember, that decimal point really does exist right there. It's just not there right this. All right, our last problem like this is 7.1. So 7.1, and now we're dividing by 10 to the second. So our decimal point is going to move once, twice, because remember, our decimal point moves in the opposite direction because our number is getting smaller. That is equal to 0.071. All right. This problem is called complete the pattern. So if I had 0.043, then I had 4.3, and then I had 430, what do you think is going on here? Do you think they're multiplying by 10, 100, or 1,000? Or are they dividing by 10, 100, or 1,000? So how is the value of the 4 changing as we move to the next term in the sequence? So how is this 4 changing? Well, it's pretty small here, and it's getting larger. The number is getting larger in the sequence, correct? The 4 shifted 2 places to the left. It shifted, the 4 shifted and got bigger. So the 4 shifted 2 places to the left. So each number is so if the number is getting bigger, what operation am I using? Is it multiplication or is it division? So each number is being multiplied by 100 because my number got bigger by once, twice. Oh, interesting. So this was multiplied by 100. And then I ended up here. Now this guy, and I ended up with this guy. If I multiply this guy by 100 once, twice, oh, look at that. I ended up with 430. So what if I continue this same pattern? That's what this is asking you to do, is to continue the pattern and get the next numbers. Yes? Now, this one right here, I'm starting with 6,300,000. Well, wait a minute. It looks like the numbers are getting smaller. So if here we're multiplying and the numbers are getting bigger, what operation do you think you're using down here to get smaller numbers? Down here, we're going to divide to figure out the pattern. So what you need to do is figure out if it's dividing by 10, is it dividing by 100, or is it dividing by 1,000? And then if you have to figure out the pattern. So right here would probably be easiest to figure out the pattern and then apply that pattern to these two areas. All right. All right, so good luck on your problem set and check back for the debrief.